Hello everyone, welcome to Brain Blitz Audios. Today in this episode of JEE Main, we'll be looking at previous year questions of mathematics asked in engineering entrance examinations in India. Today we're dealing with another very important chapter for engineering entrance exams, and the name of this chapter is Matrices and Determinants. This is a topic that is taught in grade 12 and it's one of the 20 odd chapters which are important for studying one's way into an engineering entrance exam. So today is a very short set but with very important questions, so I urge that everyone watch the entire episode because we have various types of questions involving matrices and determinants. So without any more delays and obstructions, let's look at our first question. This question was asked in 2002 and it goes: if the value of a is greater than 0 and the discriminant of ax squared plus 2bx plus c is negative, then the determinant of a, b, ax plus b, b, c, bx plus c, ax plus b, bx plus c, 0 is. So we have this determinant and you need to find the value of that determinant. So how do we solve this question? We have to use the methods of solving determinants in order to solve this one. So first we will write this big determinant over here. So we'll write a, b, ax plus b, first column. Second column is b, c, bx plus c. And the third column is ax plus b, bx plus c, and 0. Now, what we're going to do is we're going to convert the column c1 to x times c1, basically multiplying a column with x. And when you do that, you have to divide by x outside the determinant. So you have 1 by x times, the first column will be ax, bx, and ax squared plus bx. Then you have b, c, bx plus c. Then you have ax plus b, bx plus c, and 0. So this is our current step. Now what we need to do is we need to make the first column c1 in the form of 0. So we have to make it 0. So in order to make it 0, what you can do is you can add the value of c2. For example, if you take the first row, ax plus b minus ax plus b will give you 0. So what you can do is now you can convert column c1 into c1 plus c2 minus c3. So for this scenario, it'll be 1 by x times ax plus b minus ax minus b. And then you have bx plus c minus bx minus c. Then you have ax squared plus bx, and then plus bx plus c, and then it's a minus 0 because c3 at the third row is 0, so it is not written. Then you can write the other columns as they are: b, c, bx plus c, and then ax plus b, bx plus c, and 0. So over here, you will have 1 by x times. In the first column, it will be 0, 0, and ax squared plus 2bx plus c, and then the second column is b, c, bx plus c, and on the third column it will be ax plus b, bx plus c, and 0. So in determinants, once you have done all the simplifications that you can, what you do is you take the expansion of the determinant along any column or row. And when you're taking the expansion, it's good to take expansions which are easier to do. So in this case, if you take the expansion along R3, then it will be a big problem because you have to multiply big terms. However, if you take C1, you notice that two of the elements here are 0, so therefore you only have to do it for the third element. So now what we do is we expand the determinant along the column C1. So therefore it will be 1 by x times, let's take a big bracket so that we can write everything inside. So ax squared plus 2bx plus c, and then times, you will have b times bx plus c minus c times ax plus b, and this is the expansion along C1. The other two terms are 0, so whatever is the expansion on inside their brackets, it will still be 0 because the term outside is multiplied with 0. The whole term is multiplied with 0 on the outside, so the other two terms are 0 and 0. So you don't need to write them. Now what we do is we simplify whatever is inside the bracket. So ax squared plus 2bx plus c remains the same, and inside you will have b squared x plus bc minus acx, and then minus bc. So you have bc canceling each other out, and you can take x common from b squared x and acx. So you have ax squared plus 2bx plus c divided by x multiplied by x, because that x is taken outside, and then you have b squared minus ac. So over here the x and x gets cancelled, and you have ax squared plus 2bx plus c and b squared minus ac. Now in our question, the discriminant of ax squared plus 2bx plus c is given as negative. So this is the discriminant. So this discriminant has a negative value, and the value of ax squared plus 2bx plus c has to be positive, because it is basically a square of something. So any square, whether it's positive value or negative value, will give you a positive number, as long as it's not a complex number. So for real numbers, mostly you will have the square of any real number to be positive. So the square of any real number is positive or 0, so there is no compromise there. So you have positive times negative. Now we're just taking the sign here because that's what's important. So you can write positive times negative as equal to negative. So therefore, if you look at our question, then you can see that option C, negative, is the correct option. So here the determinant is not equal to 0, and it's not a positive value, it is negative. So in this question it's just enough to find out the sign. So you don't have to find the exact values of what happened, you just need to find out the sign of it, and that's why option C, negative, is the correct option. This is the next question. If L, M, and N are the pth, qth, and rth term of a geometric progression, or GP, all of these terms are positive, then you need to find out the value of the determinant log L P1, log M Q1, and log N R1. So the value of the determinant will be equal to. This question was again asked in 2002, And it's a very important question because it uses the concept of progression that we've studied in grade 11. So in a geometric progression, any term can be represented as AR raised to x minus 1. So suppose we have L. So L here is the pth term, which we can write it as TP. So L can be represented as AR raised to P minus 1. So in this case, A equals the first term and R equals the common ratio. So in a geometric progression, we will have a common ratio between all of the elements. So, and you would just multiply n minus 1 to the common ratio and then multiply that to the first term in order to get a particular term. So L equals AR raised to P minus 1. But then our determinant is based on the values of P and Q and R. So how do we adjust that? So what we can do is we can take log on both sides. So when we take log on both sides, on the left hand side you have log L, and on the right hand side you have log AR raised to P minus 1. So log A times B is equal to log A plus log B. In this case, B is R raised to P minus 1. And R raised to P minus 1, so that is log x raised to A is equal to A log x. So therefore log L will be equal to log A plus P minus 1 times log R. So therefore this is a standard way of representing the logarithm of the term of a geometric progression, that is L. So the pth term L is represented as log L equals log A plus P minus 1 times log R. So you can write similarly log M. So since M is the qth term, so it will be log A plus Q minus 1 times log R. And for log N, it will be log A plus R minus 1 times log R, because in this case N is the rth term of the geometric progression. Now we go back to the original determinant whose value we need to find out. So that determinant can be written down as log L, log M, log N as the first column, P, Q, R as the second column, 1, 1, 1 as the third column. Now this determinant, we can substitute the values of log L, log M, and log N. So now the determinant will look like this. It will be log A plus P minus 1 times log R, log A plus Q minus 1 times log R, log A plus R minus 1 times log R. And then you have P, Q, and R, 1, 1, 1. So now you have this form of the determinant. So over here you have substituted log L, log M, and log N. So now what do? We can just solve the bracket from here. So it will be log A plus P log R minus log R. Now this might sound tedious, but it is very important, so keep doing it. So log A plus Q log R minus log R, log A plus R log R minus log R. So again, the R inside the logarithm is capital, while the ratio, that is R, we write it in lowercase. So this is how our determinant now looks like. how do we convert it even further? So from here onwards, you can actually split the determinant into two different determinants. So that is a inherent property that we can use here. So what we do is we take log A minus log R on one determinant for the first column. So that will be PQR 1, 1, 1. And then in the second determinant, we're taking the intermediate terms. So this P log R, Q log R, and R log R come here. And this selective way of choosing the first column for both the determinants will change the game of solving this equation, this determinant, quite easier. Because now what we can do is we can take common terms out. So when we take common terms out from the determinant, from the first determinant you have log A minus log R common across the determinant, the first determinant. So you have 1 P1, 1 Q1, 1 R, and 1. And then in the second case, you will have log R as common across C1. It will be P P1, Q Q1, R R1. So why would I take that out? Because now what we can do is we can use this property, we can use a particular property of determinants. When two columns or rows in a determinant are identical, its value, the value of the determinant, is 0. So as you can see, in the first determinant, column 1 and column 3 are identical, so it will be 0. And then in the second determinant, column 1 and column 2 are identical, so the value will be 0. So the total value for this entire determinant, that is log LP1, log MQ1, log NR1, will be actually equal to option D, which is 0. So the important thing here is to use the idea, the general representation of a geometric progression, that is a r raised to n minus 1, and then take log on both sides. And after taking log on both sides, it's merely a question of substitution and then using the property of and converting the determinant into 2, and then using the property of determinant that when two columns or rows are identical, the value becomes 0. So by doing that, we get the value of 0. Option D becomes the correct option for this question. Let's look at this question. If 1, omega, and omega square are the cube roots of unity, then you need to find out the value of the determinant 1, omega raised to n, omega raised to 2n, omega raised to n, omega raised to 2n, 1, omega raised to 2n, 1, and omega raised to n. So in this question, we're given the idea that omega is a cube root of unity. Now what does this mean? This means that if we take the cube of omega, which is omega cube, it will be equal to 1. So omega raised to 3 is equal to 1. Now this property can extend across all multiples of 3, so we can further write that omega raised to 3n is equal to 1. Now why would we want to use this property? We can find that out when we expand this determinant. So you have 1, omega raised to n, omega raised to 2n, omega raised to n, omega raised to 2n, 1, and then omega raised to 2n, 1, and omega raised to n. This is basically a symmetric. Now if this was a matrix, then it will be a symmetric matrix, but over here it's a determinant. So what we're going to do is we're going to expand the determinant along its first row. So expanding the triangle determinant along R1. So this triangle is what we call delta. Expanding delta along R1, you will get delta is equal to 1 times, so this is the first term, and then we hide out the elements on the same row and same column. So you have this determinant, so that we can write that as omega raised to 2n times omega raised to n minus 1 times 1. Then you take minus for this case. The reason why it's minus is because of its position. And then the second term here on that row is omega raised to n. And then open the big bracket. And then you need to take 1, 2, 3, 4. These 4 terms as their determinant. You have to take their determinant. So it will be omega raised to n times omega raised to n. And then minus omega raised to 2n times 1. And then you need to add, so put the plus sign. And then the third element is omega raised to 2n. Open the bracket. So over here you have these 4 elements. So basically it will now be omega raised to n times 1 minus omega raised to 2n times omega raised to 2n. So on further solving this expansion, you can see that omega raised to 2n times omega raised to n will be equal to omega raised to 3n and then minus 1. Minus inside the bracket adjacent to and multiplied to omega raised to n, you will have omega raised to n times omega raised to n as equal to omega raised to 2n minus, there's already an omega raised to 2n here, so that's settled. And for the last bracket, you will have omega raised to 2n times omega raised to n minus omega raised to 4n. So how do we solve further? We know for a fact that omega raised to 3n can be considered as 1. So over here the value of omega raised to 3n is equal to 1. So basically you have 1 minus 1 minus omega raised to n times, these two terms cancel each other out, so that's 0, plus omega raised to 2n times, what you can write is, you can write it as omega raised to n minus omega raised to 4n can be split to omega raised to 3n times omega raised to n, and since omega raised to 3n is equal to 1, so you will get omega raised to n on that side too. So basically this also cancels each other out, and 1 minus 1 is also equal to 0. So the final value of the determinant delta is once again equal to 0. So for our question asked in 2003, the right answer is option D, 0. So over here the important thing to note is that using the given cube roots, you can use the root omega, and using that cube root you can find out the expression that omega raised to 3n equals 1, and then from there onwards it's just a matter of expansion of the determinant and then substituting and then converting that expansion into terms using omega raised to 3n, and you will get your answer as 0. Let's look at the next question. In this question, if the matrix A equals A, B, B, A, and the matrix A square equals alpha, beta, beta, and alpha, we need to find the values of beta and alpha. So this question is comparatively simple. So what you can do is, you know the value of the matrix A, which is A, B, B, A. So essentially you can write the matrix A square as the multiplication of the matrices A and A. So it will be AB BA times AB BA. So A square is now equal to, so A times A is A square plus B times B is B square. Then you have AB plus BA, AB plus BA, and A square plus B square. Now note that when you're doing multiplication, we take the first row and the first column, then the first row and the second column, then the second row and first column, and then the second row and the second column. So a good way to remember this is to think of it as a 7. So one part of this is from the horizontal branch is from the first determinant, and the vertical branch is from the second determinant. So by remembering it that way, you can not make an error, because you'll know that using that 7 method you'll have to take one row and one column at a time. So A times A is A square, B times B is B square, so you add them up as one term. B times B is B square, and then B times A is AB, A times B is AB, so you can add them up, and using that multiplication we get this this matrix. So we already know that A square equals alpha, beta, beta, and alpha. So therefore alpha, beta, beta, alpha is now equal to the matrix A square plus B square, 2AB, 2AB, A square plus B square. So for the element alpha, the coinciding element is A square plus B square, and for beta, the coinciding element is 2AB. So alpha equals A square plus B square, beta equals 2AB. So this equation, these two equations give us our correct answer. So option A, alpha equals A square plus B square and beta equals 2AB is the correct option. This question is based on matrix multiplication. So if you can multiply two matrices correctly, then the answer is very simple. So once again, the matrix has to be multiplied based on the 7 method, one row multiplied to the other determinants column. And that's how you progress. Again, matrix multiplication has its own, techniques and conditions. You can always view that by clicking on our videos regarding matrices and determinants as we solve CBSE board questions. So you can always check out on that and learn more about matrix multiplication. So now let's look at the final question of this episode. We have a matrix A, and it's given as 0, 0, minus 1, 0, minus 1, 0, minus 1, 0, 0. We need to find out the correct statement among the following. This question was asked in 2004, and the options here talk about various stages of a matrix. So in this matrix A, option A says that A inverse does not exist. So for A inverse to exist or not, the determinant of A has to be found out. The determinant of A for this case will be equal to minus 1 times 0, minus 1, minus 1, 0. That is equal to minus 1 times 0 minus 1 into minus 1. So that is minus 1 into minus 1. So the determinant of A is equal to 1. Now, whenever the determinant of A is equal to 0, A inverse does not exist. So over here, the determinant of A is not equal to 0. Therefore, you can write that A inverse exists. So since A inverse exists, you can write that option A is incorrect. Now let's look at option B. In option B, it says that the value of the matrix A can be written as -1 times I, where I is considered as the unit matrix. So the matrix A, when we write it down, it is 0, 0, -1, 0, -1, 0, -1, 0, 0. However, if you take -1 times the unit matrix, it will be equal to -1, 0, 0, 0, -1, 0, 0, 0, -1. So as you can see, both these matrices are completely different. They might have the same elements, but the order in which they're arranged is important. So therefore, when you look at that sense, -1 times I is completely different from A. So therefore, you cannot write that A equals -1 times the unit matrix. So option B is incorrect. Now, if you take a zero matrix is basically a matrix with its values as 0. So you have all of the elements inside a zero matrix to be equal to 0. If you look at A and a zero matrix, they are completely different once again. So therefore, option C, A is a zero matrix, is also incorrect. The right answer for our question will be A square equals I. Now, how do we prove that? Very simple. You just need to multiply A to get A square. So A multiplied by itself gives you A square. And in this scenario, it is 0, 0, -1, 0, -1, 0, -1, 0, 0. And then you have 0, 0, -1, 0, -1, 0, -1, 0, 0. This multiplication is a little different from what you usually use to multiply. It's matrix multiplication once again. So first things first, you take the first row of the first element, the first matrix, and the first column of the second matrix. So 0 times 0 is 0, 0 times 0 is 0, -1 times -1 is +1. This is our first term of the combined matrix. Now you take the second column, 0 times 0 is 0, 0 times -1 is 0, -1 times 0 is 0. And similarly, for the third row, you can write 0 plus 0 plus 0, because 0 times -1 is 0, -1 times 0 is 0. So now, after taking all three columns for the first row, we move on to the second row. In the second row, you will have 0 times 0, again 0, -1 times 0, again 0. 0 times -1 is 0. Now we take the second row, the second column of the second determinant. So over here, 0 times 0 is 0, -1 times -1 equals +1, and then 0 times 0 is 0. For the third row, it's essentially 0 plus 0 plus 0. For the third row, you have 0 plus 0 plus 0. You can do that on your own, and you will get the same values. And for the final row, -1 times -1 equals 1, plus 0 plus 0. So basically, what you get is A square equals 1, 0, 0, 0, 1, 0, 0, 0, 1. And this matrix is what we call an identity matrix. So therefore, A square is indeed equal to I in this question. So therefore, option D, A square equals I, is the correct option. So over here, the other statements are not correct, because for the matrix A, the determinant is not equal to 0, and then it's completely different from the other options B and C given. So you can either prove the other options wrong to yourself and take the right answer right away, or you can do all the four. But then for entrance exams, time is of the essence, and therefore the earlier method of elimination works perfectly. So that concludes this episode of JEE Mains. We hope you found it interesting. For more videos on various chapters, you can hit the link of the playlist in the description down below. For matrices and determinants, we have also made a series of videos regarding CBSE board exam questions regarding the same chapters, so you can always go to our website www.youtube.com/c/BrainBlitzAudios. You can also subscribe to our channel to get updates on more of our useful and interesting content. So until the next webisode, take care, stay safe, bye bye for now.